The next talk, and it's the last talk today, is AI-driven tool deployment by Sebastian Lopez Marcano from the Data Science CRP here at University of Queensland. This will be great to cap off what's been an awesome day digging under the hood of AI. And then after that, we'll have a panel discussion with the speakers and try to get everyone involved and ask some of those thorny questions that were starting to pop up at the end there. And we kick the can down the road to the panel session so you can, think about those for afterwards. So over to you, Sebastian.
Thank you. Good afternoon, everyone. So just to start, I will say I'm not a mathematician, okay? My background is marine science. I worked with fish and sea cucumbers and coral reefs. But the past few years, I've been working in agriculture. But one thing that is common in all of my career is that I've done tool deployment. And when I refer to tool deployment, any apps from your phone or computer, websites, things like that. So that's the general skill that I've brought from all these different domains that I've worked. And I kind of want to show you today how to do that with AI. So that's why I presented to the team and so on that I wanted to really have a talk about AI-driven tool deployment. So I work in a team here at UQ called the Data Science Collaborative Research Platform, or CRP. And it's essentially a central team that provides data science and AI expertise to teams across the whole university. So I work with agriculture and environment. And the sort of stuff they're going to see today is my day-to-day job. And I know a few people here have seen what, as a group, we have been able to collectively do for agriculture tools, essentially. All right, so the general steps that every tool makes, and again, this is any tool, doesn't need to be an AI tool, is notebook, packages, server, and then it goes into people's hands. I'm sure that maybe if you have deployed tools or use coding tools, you have maybe seen these sort of steps a few times. But with notebook, I'm referring here to things like Jupyter Notebooks or a Python script, an R script. Then you move into packages where you're doing maybe reusable tested code. Then you move to maybe a server, which is a virtual machine that is enabling the usage of those packages and functions that you have created. And then finally, once the application is live and in production, you give it to people and then you start getting some sort of usage statistics, but also maybe potential feedback. But just to give you maybe the same path of all these or the steps in a agriculture focus, I've added here the 4 steps of what it would be to develop maybe a new crop variety. So the notebooks would be like doing experiments in the glass house. The packages is like the field trials. The server is when you start looking at seed increase. And then when it gets into people's hands, it's more about grower paddocks, right? You're now growing the seed, making it available for people, and then maybe getting some sort of profit or return out of that. All right, so those general 4 steps can be subdivided into what I'm calling the deployment pipeline. And this would probably be the key takeaway of my talk today, and is going from the code to the cloud, okay? These the steps that you're seeing here in the pipeline are very similar to the 4 steps that I showed you before, but as I said, they're subdivided. So in terms of notebooks, you're looking here at code and things like GitHub. For the modularization or packaging of tools, you're looking here at containers and APIs. And then for the server, you're looking there at virtual machines and cloud. And my presentation is going to go through all of these steps. And I know, because of the different people that are here, I know that maybe you are at different stages of this process. The purpose of this talk is also not for you to be able to do it yourself, but so you understand that if at any point you want to do it, which are the things that AI can help you and which are the things that maybe a human expert will need to assist you. All right, so moving forward, whenever you see that little star maybe on the top right of an icon, though that is a step that can be essentially helped, assisted, or supercharged by AI. And what I mean by AI is multimodal large language models, or like Claude, Gemini, ChatGPT, all these things, right? So what you're seeing there, and I'm gonna go in a little bit more into the talk, is that everything at the start can be supercharged with AI. AI can pretty much do it for you. Anything at the end of deployment is usually now humans, but that is today. Maybe tomorrow will change. Cannot predict that. But that's a general gist of this whole presentation. One thing that Christos talked in the previous talk was that there's an aspect of safety and security. And I really want to make that point across right now, that security wraps every single layer, right? And AI, again, can help you with that. But that's something sometimes you maybe have a cybersecurity expert or a data scientist that know a little bit about security. And in there, I'm referring to things like API keys, data. So Christos talks about intellectual property of sensitive data, or things like access control, right? Who can access the data? Can the agent access the data, and so on? And the other thing that we have kind of touched throughout the whole day is that there are costs to these things. Sometimes you maybe want to deploy an AI tool or any tool in your local machine, and that doesn't have any costs. But if you want to deploy it in some sort of server, which it's cloud or virtual machines, then there is a cost associated to that. And in there, things like compute, storage, and API calls all have some sort of monetary value that you need to consider. All right, so just to maybe break down that first step from code to container, in here, the four things or three things I'm gonna talk to you about are version control, clean code environments, and a bit of development or code packaging. All right, so from notebook to reusable code, I think many people here at some point in their lives, in their professional lives, you have done some sort of script, R script, Python script, Julia, whatever it might be. And that usually is a very sequential flow, right? You go and read the data, and then at the end, you produce some sort of output. But maybe sometimes you want to create a notebook, which is something, it could be a Quarto document or it could be a Jupyter notebook. And the idea is to maybe deploy it in the sense of maybe putting it somewhere in a website so people can use it, or you're putting it as part of the publication that you're writing. But most of the time when you are doing that notebook, you start thinking about maybe creating functions. And a function is a reusable piece of code that has one job, but that job is being repeated across many different steps in your code, right? And then maybe if the functions are not enough, you start thinking maybe about modular approach, right? Your sequential script now becomes steps that are running, maybe step 1 and then step 3 and step 4. But maybe those steps can also be used across other projects, right? So those are the general flow of any tool that you want to kind of develop, going from very experimentation based to more development based. And as I've shown there and now, and you can see it, AI can definitely help in all of these steps at the moment. So writing a notebook, you can say, write me a Jupyter notebook or change this. Write me functions because I want to use it in another project, or make this a little bit more modular. I'm pretty sure you have all tested these things, and AI can already do that for you. Once you start getting into maybe sharing a little bit of those modules or code to other people, you start thinking now about the requirements or environments, the coding environments in which you are developing, right? Maybe someone here has a Dell laptop, and you are now giving the code to someone that has a Mac, right? You're now thinking about, can this person run that same code as it is, as a Jupyter notebook, for example? And one of the ideas that you kind of need to know for this is environments and requirements. So requirements, if you just see there in the screen, is a text file. So it's just simply a file that has the packages and the versions of that package that you're using, right? This is something that AI can already do for you. If you say, please generate the requirements file for this tool, it will give it to you straight away. And that requirements.txt is what someone else is going to use to then run the code and replicate the coding environment that you had in your machine. So if, for example, someone had that Dell laptop, they will then go and then say, I want to install all these packages that are in this requirements file, and I create my environment to replicate what you have done, right? But from a development or developer point of view, you want to do this. So then that content environment is kind of like the setup of all of the functions, the code, and all the steps that you're going to be doing. And you want to do it in the different phases of development, like development, testing, and production, right? I am mentioning this because at some point tomorrow or maybe on Wednesday, for those doing the workshops, you will be required to install things in your Google Colab notebook using a requirements.txt or pip install Python. So again, for those attending, that's something that's going to happen for sure tomorrow. And as I mentioned, AI can already help you with this. It's fairly simple to do. All right, before I get into this slide, how has people here used GitHub in the past? Just raise hands. Yeah. Okay, perfect. For those that maybe haven't, so GitHub is a software that it's online to save specifically code and to share code with other people, right? You can see GitHub there in that middle box that is called GitHub repository. But the idea is that you have kind of like a folder that has all of your code. It has all the history of all the changes that you have done to that code throughout the entire project. And you also have things like branches and pull requests for whenever you're doing kind of like more development heavy tasks. So a branch is essentially like creating a copy of what you have done up to that point. And then from there, you do your little changes to the code that you want to maybe add a new development feature or something like that. And then a pull request will be saying, I want to merge these changes back to the production environment. So someone approves it and then says, yes, perfect, all good. The important thing about GitHub is that it's the one source of truth. It's reproducible, it's easy to share, and it's the, again, natural flow of going from my notebook that was running on my laptop to have my requirements to now sharing that work with other people. This is one of the requirements that you will see for many journals that you say, oh, I want to see the code and the data. Usually people would put a GitHub link as part of that, right? AI at this stage and as of today can help you do many of these things already in GitHub, from commit messages, pull request summaries, writing the git ignore, and even creating automated actions for deployment. We saw the example of some of the apps that have been developed with AI and so on, or potentially the apps that have been shown that are also on GitHub, and most of them are running actions that could have potentially been written as well with AI. So that's a good example of what we have seen today. Another example that I want to show you very quickly about, I guess, GitHub being used in agriculture is this example of ADAPT, which is Agricultural Data Application Programming Toolkit. It's very well known in the agriculture data science space, and it's essentially a data standard and a bit of a software or tool that enables interoperability between different software and hardware applications. And what you're seeing there on the right is a little snapshot of how the GitHub repository looks for Adapt. So they have their main branch, and then they have all the different branches that they are kind of developing, maybe with AI or not, to essentially keep working on those data standards that they're building, right? So again, a real example of an agricultural software that is using GitHub and then kind of following this process of tool deployment. One last step in this of code to container is thinking about containerization. And I think this is where many of the people that are more on research heavy will stop because it gets a little bit complex. But essentially is one of the common challenges that we'll see, and I said this before, you're running a code in a Dell laptop, but it doesn't run on a Mac, even if you have the same requirements. One of the things that you can do to solve that problem is using containers. And one of the software that many people use is called Docker. You see there in the middle. But I've explained it there pretty well. It says without containers, it works on your local machine, but it doesn't run on any other cloud, or maybe when you share it to other people, it's not working. With Docker, what you can do is essentially create a file or a kind of an environment where it wraps the code, the libraries, the runtime, the config, everything in one place. And that container you can share with other people, and they will have no issues running that code that you have developed, okay? Obviously, you will need to have like Docker installed in your laptop, for example, if you're running it locally, but it's one of the things that many people kind of need to know when you're thinking about deployment, containerization of tools. And as I've said at the start, with these initial steps, AI can already help you writing that first Docker, the first draft of the Docker file, which is kind of like the main bit of Docker. All right, moving into step 2, we're looking at serving and running things like API, hosted models, machines, and databases. And just to go back to the deployment pipeline, we have done, I guess, the first 3 steps, and now we're moving into that blue step, the API. And I hope after today, if you don't know what an API is, you would have a little bit of an understanding of what it is. All right, so before you get into these slides, I wanted you to have a look at the diagram there that it says app, sensor, API, and AI model, right? The best simple example of what an API is the AI model is the restaurant and the kitchen. The API is the server, like the waiter, waitress, and the app and the sensor is you ordering some food, okay? So I order food, call the server comes, I want a hamburger. They go back to the kitchen, they cook it, the server brings it to me. The server is the API, okay? So I hope that's the best example that I have, and that's how I learned APIs. I love food as well. But anyways, so yeah, APIs, it's one of the protocols that most people are using. It's a request in, a request out. And one of the common languages that people are using is called Fast API. That's what, at least at UQ, we use a lot. Some of the everyday APIs that you use are like Google Earth Engine, Claude, GPT, Weather and Soil APIs, all of these things. You send a request, you get something back. Yeah. AI can already write you an API. And what I mean by that is that when you have a notebook or a code that has been containerized, it still needs to be changed to an API flow. It's a little bit different. But if you have no knowledge about how to write an API using fast API packages and all that, you could already ask one of these AI models to write it for you, and it will kind of work. So one way that you can interact with an API is using kind of like a hosted AI model, which we have seen quite a bit today. So if, for example, you have your code, your app that is running in your local machine, maybe you have an API key, right? And then you're asking Claude, GPT, Gemini, Google Earth Engine for some sort of request to solve a request, and then you get a prediction back, right? So that process there is using an API. In terms of what you are managing as a user and kind of like a manager of your app are things like the prompts, the keys, and the cost, right? Every single interaction will have some sort of cost. The benefit of this is that from the infrastructure side, from like the actual software and hardware that is running all of these AI models, they are going to be managing the things like the GPUs, the CPUs, the scaling, the updates, the cybersecurity, blah, 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 right? So if you're developing an app, this is one of the best ways that you can do it really quickly, where you have an hosted AI model using one of these like large foundational models, and then you have your app that is consuming the content from there. But obviously there's some cost to that. The other way that you can run an application is using now cloud infrastructure, and I call it rented infrastructure because this is essentially a physical piece of a machine that is somewhere in Australia or in the US or somewhere in the world that you're paying per hour to run your queries, right? And in here you have things like virtual machines and databases that are connecting with each other all the time, right? I put there on the diagram that from your API, it's going into your virtual machine, and then obviously you have maybe the database that it's interacting with that. This concept of using cloud or rented infrastructure for app development is the most common one that I've seen once you don't want to be using the hosted AI models because that's not what you're doing, kind of, for example. So yeah. With the with cloud, obviously it comes costs and things like security. So I want to touch on that for a little bit. So where to run it, what it costs, and how to keep it safe. Again, we have done APIs in the deployment pipeline. So I'm going to move now to virtual machines and cloud and show you a few examples and case studies of how at UQ, at least, we're developing things with AI. So how to choose a cloud? This is kind of like important, and I hope that you can take this as a message as well from my talk today. So with your computer, when you're deploying things locally, you have full control. Maybe sometimes you don't need internet, but most of the time you're going to have limited scale, right? It's not going to run really powerful models. And we have already said today, oh, if you want to use GPT-5, you cannot run it in your laptop, right? Because it's quite large. But you have more control there. One thing that sits in the middle between commercial cloud, which is like the fancy, I'm paying, this is what banks use, and all the other applications that we use in our day-to-day lives are using, like Amazon Web Services, Google Cloud, or Azure, are things like research infrastructure here in Australia called ARDC Nectar. And that for me is my go-to cloud whenever I'm thinking about deploying things. It makes it super easy. First thing, it's free. I don't pay for anything when it comes to Nectar, right? It's free for researchers. It is available to any researcher in Australia and New Zealand. And it already provides you a bunch of tools like virtual desktops, Jupyter Hub, and even GPUs if you want to run actual AI and deep learning computer vision models a little bit more hands-on. Okay, so if you're interested on that, I highly recommend that if you're going to deploy some apps or you want to test things, check ARDC Nectar. It's super simple. And they also have a lot of tutorials, really nice tutorials that you can use to follow the steps. But as I said, commercial cloud is always available. These are the things, once you're thinking about like really big app deployments, like again, like a bank app, this is what they'll probably be using. In terms of cost, here I have a bit of an example of hosting your own virtual machine, like kind of like rented infrastructure, and some examples there of graphical processing units or GPUs, and how much it would cost per hour to run things there. So an hour would usually come at $1, $2, $3. When you're thinking about hosted APIs per 1 million tokens, and I hope you already know what a token is already because we have covered a few times today. Here are some of the costs, right? So per 1 million tokens, you're looking at Haiku, for example, for Claude, $1, or like Fable 5, which was this latest AI model that was released recently. It costed around $10 to use per 1 million input tokens, right? I don't know if you saw, but Fable 5, for example, was blocked by the CIA in the US because it was so powerful that they kind of released it. And then an hour later, CIA said, don't use it. And they blocked all accesses to Fable 5. And now, as a researcher, if you go and do a request right now in Claude, in Fable 5, and put anything that is kind of biological in nature, agriculture, environment, blah, 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 it gets blocked. I've tried it a few times because I really want to use it. So anyways, it's a really powerful model, and the CIA in the US, it's quite scared of it. But it's very expensive because obviously it has a lot of power there. All right, in terms of security and keys, I mentioned at the start, any of the steps that I've shown you today have some sort of security or safety associated to it: code, containers, APIs, virtual machines, the cloud. And one way that AI can already help you with things is with a tool called Wiz. And Wiz, we use it here at UQ at the enterprise level, but you could also use it more like personally. But it's essentially cloud security that finds the attack path before hackers do. And the cool thing is that it's fully AI enabled. Like the whole thing is AI. You connect your virtual machines to Wiz, and it will tell you straight away if there is an attack or a cyber attack or all vulnerability happening in your code. And just to show you, like an example of this. This happened quite recently. We had a project, and I think Kavisha is here somewhere. We had this cyber threat that apparently was available now, called CopyFail, that it was affecting millions of cloud workloads. It could be exploited in the wild, and some of the projects that we had here at UQ could potentially be affected by this. But because we had WIS, we got an email saying, "Hey, you have some threats happening." You go into the website, and by a click of a button, you can fix everything that is happening. It's super cool. You don't need to code anything. You don't need to be a cyber expert as well to fix these things. So again, a real example of how AI can already help you when things like that happen. All right, and then I think this is the final section, people, AI, and the real world. I want to show you an example of a real deployment of using AI, but also some other ideas that maybe you are aware of. One thing that happens with AI now becoming more common is this idea of vibe coding. Have people heard about vibe coding before? Show hands, yes, perfect, okay, cool. So for those that don't, it's essentially a way of development in which you describe it with words and then let the AI write it and have full control of it, okay? For those that use YouTube, there's a very famous YouTube ad that appears in every of my videos, Base 44. I don't know if you have seen it, no? Okay, maybe it's me. But it's essentially one of those apps. You literally put, I want an app to track my things, and then it writes it, deploys it all like in one go, right? There are a lot of benefits of doing this. You can have features that just come from a prompt. You could have quick prototypes, boilerplates in seconds, but you definitely need to watch out for things like developing code that you don't understand, security holes, and then maybe some sort of skill atrophy. I think the first one there, developing code you don't understand, is really relevant in a university context, right? Imagine now that you want to publish something and you're developing code that you don't understand because you follow the vibe coding. It will get rejected straight away in the reviewer phase, especially if they find bugs and things like that, right? And that could bring a lot of issues to the university and your team and yourself, reputation-wise as well. So again, cool to use it, but kind of always have that human check at the end. So in terms of all the things that I showed you, so where AI can help and where you lead. So AI can accelerate things like Docker files, APIs, endpoints, infrastructure as code, explaining error messages. I'm sure that you have done a few of these things, but you still need to stay in charge, right? Architecture and design. Is the output correct? Am I tracking on the costs? Is the scale right enough? And then obviously accountability for results. All right, so I want to show you a real example, and this literally happened maybe a couple of months back. We had a project in the Aggie team, analytics for the Australian grains industry, that they're doing satellite image analytics. And the old way of us deploying an app in a dashboard that we have would take 2 to 3 months, right? With a team of 3. So we will need to grab all the code, build the GitHub, then do all the containers, and then build the API, deploy it, and all that. It takes time. It takes a lot of time to do these sort of things. But recently we tried, let's just put all of this in an AI model and then see what we get. We reduce the deployment time frame to around 3 weeks, right? And it's the same of what Christos was showing before, right? You spend maybe months doing something in the past, but now you can do it in a couple of minutes. So building with AI, all of the things like GitHub, Docker, and API would take roughly a week for a person to do it. Testing became a really important part of the process because we noticed that AI was producing a lot of bad stuff. And then deployment would take roughly another week. And as I said, that's usually a little bit more hands-on, human-based. But again, one thing that we really noticed is that the Docker files and the APIs were produced super fast, like seconds, right? They did not work the first time. We tried, did not work the first time. We had to still fix them manually, okay? So again, a good example of things that happened to me recently at work of using AI for agriculture tools in which you want to accelerate things quicker, but you still need to have that expertise in there to really fix those things. All right, so I hope that with this presentation, you take away this deployment pipeline with all the steps from the code to the cloud, that security wraps every layer, that there's some cost associated with it. You always need to be kind of checking the outputs of all of what you do. And AI, as of today, July 2026, can help you with the 4 steps out of the 6 at the start. And then everything else kind of is more for the human to do. Right, so thank you.
Do you have any questions? That's a really informative talk there. Thomas.
You mentioned that you struggled with the building of the containers with your agentic AI.
Mhm.
I'm wondering, was the problem in the dependencies between tools, or was it actually constructing the container where you were having issues, like your Docker file,
Yeah, good question. It's the answer to that is more about for the agentic tool to understand the environment in which we're developing. As you said, like the dependencies, who is it connecting to, the account that you're using for Docker, all these things, kind of when you try to do a prompt, unless you don't put it straight away, it's gonna usually have an error there. But it wasn't about generating the Docker file, because that usually goes quite quickly. It's about how then you deploy that in that context of where you play.
Just on that, can you get around it by tasking it to go out, do the README for the tools that you want to put in your container, maybe build a skill that like maps out this whole architecture so that you don't have to prompt it every single time
Yeah,
to
for
do
sure.
that?
Yeah, exactly. Yeah, that's right.
And is it possible, do you ever try to get AI to diagnose its own errors and fix them, or was it really something you had to manually do to get that container to it?
Yeah, good question. We have tried to do that, especially at the level of pull requests, and it will tell you what things are wrong. But it's very funny because I think nowadays, many people are developing code straight away with AI. You write it with AI, and then you're also reviewing it with AI with the same model. And how is that the reviewer gonna be? How is that reviewer gonna be flagging things that the actual AI was writing? I find that a little bit funny.
Yeah, I don't know. I have a different opinion on that a little bit, because it's starting from a different context,
Mhm.
right? Than the context of the LLM, the same model,
Yeah.
say Lopez, that was writing the thing in the first place, versus one that's reading what was written and trying to find a problem. They've got different contexts. So even though it's the same underlying brain and engine, the way they see it may be quite different.
Yeah, for sure. Yeah.
So yeah, but I've never tried this, so I